Yes, class. Is this audible to you people? Hello?
Yes, ma'am.
So, who are present right now? Khalid, Salman, Samaira, Sneha. Alright. So, in the last class, we had started with Biot-Savart's law. So, Biot-Savart's law's formula was simple, straightforward. Magnetic field depends on current element, sine of the angle made between the current element and the position vector, and inversely proportional to the position vector of that point. So, main formula becomes mu naught by 4 pi ideal sine theta by r square. One thing that I forgot to mention in last class is that the value of this constant, like this constant we know k is equal to 1 by 4 pi epsilon naught. This value is 9 into 10 to the power 9. Now the value of this constant in magnetics, it's not km, I'm just writing it to avoid the confusion. This is mu naught by 4 pi. This value is 10 to the power minus 7. So this I forgot to tell you people in the last class. This is mu naught by 4 pi is equal to 10 to the power minus 7. So mu naught will be equal to what? Mu naught will be equal to 4 pi into 10 to the power minus 7. Tesla meter per ampere. Yes. It will be Tesla meter per ampere. So just note it down wherever you have written no Biot-Savart's law at the end or wherever, just add this point. Then we'll start with it. I'll do the direction once again because direction is very important for all the questions. We have applications of Biot-Savart's law, there also it is required. All right, so let me repeat the directions that we did in the last class. Two methods are there for right hand thumb rule. First method we had discussed. See, you have to keep your thumb in the direction of flow of current. Like for example, this was my current carrying conductor and current I is flowing in upwards direction. And this is my point A where I have to calculate the magnetic field. So at this point A, just imagine this as a point A, I have to calculate this at point. Keep your thumb in the direction of it. This is the direction. Now curl your fingers. This is the curling of my fingers. This curvature of my fingers will give the direction of magnetic field. So this is the flow of current. This is my thumb that is there in the direction of current. Point is here. So where my fingers are going at this point? Away from the screen, mean towards me. Away from the screen means what? Out of the page. Let's take this point. B point is here. This A point is here right now. Let's talk about this A point that is kept here. So when this point A is here, see, when this A point is here right now, I have to use my right hand only. I cannot, don't ever shift your hands. Right hand rule, so use this hand only, right hand. Even in your unconscious while you are writing it down, you're writing it with your right hand. Don't ever take the left hand. Your answer will be totally different. So current is flowing, supposedly current is flowing in upwards direction. This is my thumb. Now curvature of finger at this point, these are leading into the screen. As you people can see, this is leading into, means towards you people. You people are appearing on the screen for me. So this is where, this is towards the screen. It means into the page. This is how you select the direction. So first method was this, and we had seen examples of it. Now, this we had seen, cross product was there. One method that was left, let me write down that as well. Method 2. Now method 2 says what? Method 2 says that place your fingers in the direction of current. I'll write down it simultaneously so that you people understand it. Place your fingers, not thumb. First method allowed thumb, and right hand. We are using right hand only. It's right hand thumb rule only. So place your fingers in the direction of current. Place your fingers in the direction of current. And then curl your finger towards the point where you want to find out the magnetic field. Curl your fingers towards the position vector, you can say, towards the position vector, or you can say the point that you're calculating, A, B, C, any point, or that particular point. Then when you'll curl your finger, what is left? Only thumb will be left. That thumb will give you the direction of magnetic field. So thumb gives the direction of magnetic field. Thumb gives you the direction of magnetic field. Now, how to apply this application? Theory portion you have studied. Theory portion I've made you write, and I'll give you time to note it down. Right now, let's understand this second method. Let's say this is the direction of flow of current. So by the first method we had studied in the last class, with the help of this method, let's study. See, direction of flow of current is still upwards. Now how to use this? See, let's say this is the current carrying wire. Direction of current is upwards. What did I tell? Place your fingers in the direction of current. So if this is your direct current carrying wire, or in your notebook you have drawn it, place your fingers like this in any way, but your fingers have to be placed. Good evening, Zaid. We are just discussing the second method. First method I think you people have done in the last class, so we have just started. So see, you have to see the point and curl your fingers at that point. Let's say this point is at this. Let's take this point. A point you have to find out. So curl your fingers towards a point. If I place my fingers like this is also in the direction of current. But when I curl it, the curling is towards in front of me. But my point is at the left side of this pen. So I have to curl it. If I write it like this, if I put it in this way, curling will point in this right hand side direction. I need it in the left hand side. So if I place it like this and then I'll curl, then the curling of finger is towards the particular A point. So this will be the direction. Now where is the thumb? Thumb is pointing towards me. Towards me means out of the screen. So out of the screen, this shows that when I'm talking out of the screen, it means that it is towards me. So it will be outwards for this page. So if this was point A, it will be outwards using this law as well. So any law with which you are frequent, you are able to calculate it faster, because you'll be getting semicircles, you'll be getting circular arcs, different shapes will be there, straight line will be there, infinitely straight line will be there, and figures will get mixed up. Square along with a semicircle, along with a circle, all these will be connected. So you have to find out everywhere. You have to keep on doing it fast. If you're able to curl it, if you're able to put your finger, thumb, and then see the curvature. I prefer the second method most of the time, but whatever suits you, you can write it. First method is also correct. It's just that it becomes confusing for me sometimes, particularly me, the curvatures of fingers sometimes. So I use the second method. But whatever method suits you, answer will be the same. See, you see, the answer was coming outwards also in yesterday's class. Now do one thing. With the same method, tell me what is the direction at this point B with this method only. Then we'll discuss. Yes, Khalid, right. And one more part as well. Let's say this is example 1. Let's take example 2. So mention whatever example A and not tell the rest one using this method. And if you're not able to use this, you're not able to use this method, you're not getting the direction from it, how to put it, ask me again. Whichever part, I'll explain it again. But first, try at least by yourself. Yes, Samira. Example 1B is correct. Try example 2 now. Sneha, for the example 1B B part, na? Yes, right. Example 2, yes, Khalid, right, correct. Yes, example 2 is correct. Let's discuss it then. Any other answers coming? See, for the B part, current is moving where? Current is this, point is located here. This is our point. Just imagine a point here. Salman's answer is here. Example B. Okay, first example, second A, correct. Yes, fine, right answers. Now see your B point, just say your B point is here, for example, and this is the direction of current that is flowing. So how can we put our fingers? If I place it like this and I curl it, this is leading towards me. I want my fingers to curl towards the point. So if I take it like this and then I'll curl it, this is point B. So this gives me the direction of current. So this is leading into the page. Similarly, for the example 2, first part means A part, this is the direction of current that is flowing to downwards, and our point is where? Our point is here. This is our point. Current is flowing downwards. So if we keep our finger like this, current is flowing downwards and I have to have it. See, this will be the direction. As I curl the finger, this will lead inwards into the page. Similarly, for B part also, this is the direction of flow of current downwards. I'll curl the finger because B point is located here. This will gives what? This gives direction of thumb is pointing towards me. That is out of the page. So this is the way you can use method 2. So whichever method suits you, you can use any of this method. Now do one thing. We haven't done any numerical, no. So let's do a question on it. First, note this down. Note this point down, and then I'm giving you a question. Try it. Formula based question I'm giving right now. And that is a question from your NCRT. So you have to calculate the magnetic field at this point P due to this current element at the origin. So this is the current element at the x-axis. So now you know how to give the direction as well. If this is the direction of flow of current, this is your point. So see which unit vector xy has been given, so that you know how to give the direction I cap, j cap, k cap in terms of this. And magnitude you can calculate. This is r, dl is given, current is given. So try the calculations, aren't tough. And yes, for mu naught, use 4 pi into 10 to the power minus 7. This one. Mu naught is equal to 4 pi into 10 to the power minus 7. Use wherever required. Z, check the magnitude once again. And what about the direction, Z? Direction also?
Z-axis.
This is how you'll answer.
No way. The magnetic
That's
field
when the-
acts along the positive Z-axis.
No, Zed, I'm not asking you to give the complete sentence. It's okay if you will answer in words in my class. That's all right. Whenever axes are given to you in any question and you have to write the answer, see, options are not given towards x-axis, y-axis. Your answer is right. You have to mention the unit vector. Clear?
Yes.
So try the question once again, see the magnitude, and then write the complete answer. And others also try. Only Zaid has tried this question. Khalid, Salman, Samaira, Sneha. See, whenever you are answering for the magnetic field or any vector quantity, you people know magnetic field is a vector quantity. So whenever vector quantities are given, and do one thing, make this as, then your calculation will become easier. Make this as 0.001, add one more zero to it. Now see what's your answer, and answer is coming, and give the complete answer along the direction. See, you have studied two methods to calculate the direction. Like Zaid, your answer was right. But when you write the final answer, you can write it along Z axis. That is also correct. That will be fine. But when the axes are specifically mentioned, do try to write it in terms of unit vector. So others also try to answer it in terms of unit vector and give a complete answer. This we had studied in the last class, I believe. This is the direction of current and the point is here. So just take it as it is. And this is the separation. This is given to you as the separation. Means R is this. This is DL. Current is 10. Let's discuss it then. No more answers are coming. Samaira, yes. Magnitude is right. Okay, fine. But as I've told you, unit vector is not z cap. You people can write along positive z-axis also. If you mention positive z-axis, that is also correct. But it's better if you complete it in terms of unit vector. That will give you the complete definition. Why? Because in this question, if you write along z-axis, that is right. But in most of the questions, what happened? You have to have different magnetic fields, and then you have to take the sum of it. So if you have different magnetic fields, and you know in terms of I cap, J cap, then your calculations become easier. That's why I was suggesting you. Otherwise, writing along z-axis like this or outwards, that is also fine. And don't write outwards if axes are given, because positive z-axis can be inwards as well. That is not a single condition that positive z-axis will be outwards. If you write it as outwards, Samaira, that means outwards. Why it can be outward? It can be inwards. Z-axis can be anywhere. We know that it's along z-axis. Now, how it's along z-axis? For all those who were not able to do. And yes, what happened others? Sneha, did you calculate the answer? Did you try? Sneha? You tried. So where was the issue? Where you were not able to understand? In the direction or in the calculation?
Ma'am, in the calculation, I was doing the calculation. I did a mistake in between.
Direction you were able to calculate? Find out? Yes, Neha? Direction you were able to find out, no? Okay. All right, fine. Then that's okay. See, our vector is here. Means the current is here. So this will be the direction of flow of current. The point is here. P point is located here. If I curl my fingers towards this point, thumb is moving, which you were mentioning, Samira, is outwards. Outward means positive z-axis. Now I won't write the answer as outwards, because outwards gives me positive z-axis that I know that it's z-axis. But z-axis can be anywhere. So that's why, just to be precise, we know. And the unit vector. Which unit vector we use? Samira, can you answer? Which unit vector we use for a positive z-axis? Yes, positive z-axis. What is the unit vector? K cap. Exactly. So that completes your answer. Now let's write the formula of Biot-Savart's law. It says what? Mu naught divided by 4 pi IDL sine theta divided by r square. Sine theta you can easily see. What is the angle made between both of them? 90 degree. Sine 90 is 1. So there is no problem of angle. Obviously, x-axis and y-axis make an angle of 90 degree. That is not the major problem. Mu naught by 4 pi is what? This is equal to 10 to the power minus 7. Current is 10. dl is 10 to the power minus 3 divided by what is r square? This is 10 into 10. So 10 gets cancelled. 10 to the power minus 3. This becomes 10 to the power minus 10. And again 10 to the power minus 1. That becomes 10 to the power minus 11 K. This was the answer. Simple answer. Everything was given in terms of point and 1 and zeros only. So calculation was easier. And yes, initially, like your Khalid, the magnitude you were getting initially when it was 0.01, that was also right. 10 to the power minus 10 it should come that time. But right now the answer is 10 to the power minus 11 K cap. Note this down, then we'll move forward. One more thing, you might get charge and velocity, and you must be asked to calculate the magnetic field using Biot-Savart's law. So we'll modify this law. If charge and velocities come, usually this formula only gets used. These kinds of question come where point is mentioned and you have to write out the direction accordingly. So in this way only questions will come and this law will use. But current and velocity, if it is given to you, current is what? Formula of current in terms of charge and time. Yes, Salman. What is the formula of current in terms of charge and time? Salman is not there. Anyone else?
Ma'am, what is the question again?
Formula of current. What is the formula of current? If charge is given to you, what is the formula of it? Salman,
Charge
how
by
are you now? Last class also, I think you left in between, no, everything. How are you? Are you feeling better now? Yes, Khalid, in terms of charge.
Q by T.
Q by T. Definition of charge is what? Current is what? Current is basically charge per unit time. Okay, Salman, take care. Just let me know if you're not feeling well today as well. Just text me in between if any issue is there. So current is dq over dt. This is the definition of current. Current is rate of flow of charges. The amount of charge that flows in 1 second. That is the formula of current. So current is there. Now, what was your main formula? The main formula is mu naught by 4 pi ideal sine theta by r square. Put the value of dq in this. So if you put the value, b will become what? Mu naught by 4 pi is there. Instead of I, write down dq over dt. This is I. The rest of the term dl sine theta divided by r square. Now, can anyone tell me what is this quantity? dl divided by dt. Anyone from the class?
Ma'am, is it velocity?
Yes, sir, exactly. He is correct. Velocity. Current element is what? It's basically the distance that we take. SI unit is also meters, no? So distance divided by time, that gives velocity. So now the new formula of Biot-Savart's law becomes dq will be remaining and velocity will be there, sine theta divided by r square. So this is the formula that you get in terms of velocity and charge. So if you get this, no, you will either get to write down this formula by substituting current and velocity, or you can get very simple direct formula based questions. Velocity will be mentioned, charge will be mentioned, or it might happen charge is not directly mentioned, current and your time is given, so you have to find out charge. If length is missing, velocity and charge are given, use this formula. Now, there are various applications of Biot-Savart's law which is used a lot in your numericals. Not only for your CBSE exams, for your JEE, for NEET, for any competitive exam as well. These applications are constantly used, and along with their derivations, because you're in 12th, you have to appear for board exams as well. So you have to remember all the derivations, and along with the derivations, you have to remember their formula, because only the derivations won't be asked. You will get a complete question. Infinite wire will be there along with a semicircle. Different instruments will be connected, or only a simple circle can be given, an arc can be given, different materials will be given to you. So you should understand. Until you remember the formula, how will you put in the values and get the final answer? Direction still you can do, because direction rule is same for every material that is there, or every different shape. But for the calculation of different materials, first let me tell you what are the applications of it, so that you have an idea of it. Applications of, and the remembering of these formula will only become clear if you practice it. by the usage of it, then only you will be able to learn. Otherwise, it will be confusing. Where it was 2r in the denominator, where it was 4r in the denominator, where we have to put the angle, where do we have to write r square. These things will become confusing. So try to do the assignment that will be given along with it. So assignment, new assignment I think has been updated. Yesterday was a message in the group as well. Sneha, you're connected on the group, WhatsApp group?
No,
You're not there?
no, ma'am.
Okay, okay. I'll add you on the group as well. So on the group also it has mentioned that assignment was updated. So just check. It is the assignment. I think only 2 questions I gave you. 2 questions were there on based on buyout service. So also try, at least try that. In the next class, we'll discuss it if you have any doubts, or if you're able, when you will do it, submit it. Either submit it personally or best if you submit it on the WhatsApp group. I'll check it. So magnetic field due to straight wire you have. Magnetic field due to straight wire. So this has both the wires, the finite length wire and infinite length wire as well. So finite length wire is there, infinite length wire is there. Then apart from straight wire, if the wires are curved, means magnetic field due to circular wire. Now circular wires consist at the center if it is asked, at the axis if it is asked. Axis, I'll tell you how to calculate at the axis, and the formula for axis only is difficult. Circular is, center is very easy. Axis formula is a little bit lengthy, but with time you will be able to recall it if you keep on practicing. So and semicircles are there. So semicircle, circular arc, all these come in the circle only. So that we'll see. But let's start with infinitely long wire. Magnetic field due to infinitely long wire. And if you still have issues in the calculation of direction, to find out the direction, you can ask again. Now see, infinitely long wire. Let's take the first case. Let's talk about it. This is a wire. It has ends from plus infinity to infinity. It is extending. And we take a random point P. Let's say the separation of this point with the current element that we take. This is A. This point is A. And P point, we have to find out the magnetic field. Current is flowing in this direction. So you will be given these kinds of figure. So quickly you have to do, either do it this way, this is pointing into the screen, or do it in this way, this is pointing into the screen. So you should have practiced that you are able to do it fast, quickly in the exams. So in the exams you will be doing like this. You have to do it to find out the direction. You have no other option for it. And the second case is if it is semi-infinite. Semi-infinite means point lies near the wire. So you have to remember the formula of it. Formula says B is equal to mu naught I divided by 2 pi A. Remember this 2 pi, 4 pi, these become very confusing at the end, whether it was for semi-infinite, whether it was for infinite. So I would suggest you to keep on writing the formulas and highlight them so that you remember infinitely long wire, full infinitely long complete wire, then this case. Semi-infinite wire. Semi-infinite means infinity at one end and finite at other end. Means this will be infinity at one end. Case 2 says this is infinite at one end. Means this end, this is fixed. Let's say O point, this is fixed. At this point, it is leading to infinity. So one point is fixed, finite, other is infinite. We call it as a semi-infinite wire. The wire is semi-infinite infinite. And where does the point lie? The point doesn't lie above the infinity point here. The point is lying at the finite end. So I'll mention that also. Point lies near fixed end. Then the formula for this, it becomes mu naught I divided by 4 pi a. This is the formula for it. Mu naught by 4 pi a. These are the formula. Now, one thing from by looking at this, can you people tell me what will be the nature of graph between B and A? If I plot a graph between magnetic field and the radius vector A, what will be the relation? How will the graph look like? Straight line, hyperbola, parabola? Which way?
Ma'am, for straight line, then bent.
With A. No, see, in this formula, you can see how B is inversely proportional to A. So in this case, direct graph will be simply hyperbola, where it is inversely proportional. Clear? So
Yes.
do one thing before we move on to anything, just note it down. Otherwise, everything will get mixed up. Start noting it down, then we'll move on to different things. This you have written from current. And in vector form also, if in vector form if it has to be represented, multiply and divided by r, this becomes r cube. R and b, this will become mu naught by 4 pi. dq will be there. V cross r will become this time divided by r cube. This is in vector form. But for our numericals, I have seen most of the questions getting directly solved from the normal law. Initially, we used to write down the derivation. We used to teach about the derivation of this. In fact, but now you just have to remember the formula. Derivation has been deleted. And Salman, if you're not feeling well, you can take the screenshots and then later note it down. If you are feeling strained or not feeling well, so it's okay. If you're not able to write.
I am actually noting it down.
Okay, okay. See, this is an infinitely long wire. All right, I haven't written it, but I'm telling you orally. So this is infinitely long wire. B point lies over here. A point is here, C point is here. So this is the finite end. So at C point, it acts as a semi-infinite wire. Here, A point is normal point that you have, like this case that you have studied for infinitely long wire you have studied. So that will be for infinitely long wire. C point will act for finite wire, semi-infinite wire. And B point is on the axis of this. Now tell me the magnetic field at A, B and C points. At least answer for the A part. A and C part you people can answer with direction. B, I'll tell you. For A, this is acting as an, I'll write it down. Infinite. For C, it's semi-infinite. Khalid, see, your magnitude is right. That is perfect. Your magnitude for A and C both are coming equal. No, Khalid. Both of them won't be equal. Check the formula. I have written two different formulae for the infinite case and semi-infinite case. This magnitude is correct for the first part. Now see, you're writing K cap. There is no z-axis or x-axis or y-axis mentioned. This is not a graph that I have drawn. No, this is a straight wire. earlier we had the axis, so we knew that outwards will lead us towards the positive x-axis, z-axis. So we Z is answered. And no Z, no, just check again. Put the value of mu naught by 4 pi, take it as 10 to the power minus 7. And also try to mention the direction. This direction we have studied so much by two methods. If this is the current element flowing towards upwards, then what will be the magnetic field at this point? A, B, we have seen so many cases. C point, yes, Khalid. Now it's right. For C points, it's right. Samaira, you have answered it for the C part. Check your the formula again. I think you've by mistake interchanged it. B, no, Khalid. B is incorrect. And Khalid, your answers won't be accepted in the exam. They won't be accepted until you write the proper direction. You can write it into the page or out of the page, inwards, outwards. Into the page and out of the page. This is valid completely. You can put a cross and dot. You will be seeing throughout till I think it is your lesson of AC, alternating current. Cross and dot only will be used. So mention it. B part, try again. And Samira, check the formula. I think you wanted to answer this for the C part. This will be the answer for C part. But tell me the direction. See, now I am discussing it. Someone has answered. No, not clockwise or anti-clockwise. Inwards, either it will be like this, moving into the page, or it will be outwards, moving out of the page. So write into the page or out of the page. That is sufficient. Even in your NCERT, it is mentioned like this. Put a dot or a cross, whatever is your answer, outwards or inwards. That is valid. If you are sure that outwards at z axis, then write it as k cap. If you're not sure, then just write it as inwards or outwards. That is also valid. Let's discuss it. And clockwise direction is not possible. No. Clockwise is the direction of your curvature of fingers. You're going according to it. See, that's not the direction. What did I tell you? Where your fingers are pointing, that is the direction. If you are, okay, this was the second method. The first method was this. If you are getting like this, it means outwards. Fingers are pointing outwards. That's how you see. Don't look at the curvature, means don't see if it is going clockwise or anti-clockwise. Otherwise, clockwise, anti-clockwise, it's not possible. This is not rotation. Clockwise, anti-clockwise are possible in case of rotational analogs. Like torque, when we did torque, we had clockwise and anti-clockwise direction. So for that, remember. Let us calculate. A part, let's go systematically only. For the first part, A part, magnetic field at A part. So A part is what? A part is your infinite wire. Formula for infinite wire is what? Mu naught I by pi A. This mistake is done a lot by students. Instead of writing 2, they write 4 and their answers come. Whatever answer should be for the C part. Mu naught can be written as 4 pi into 10 to the power minus 7. Current is 10, 2 pi. And A is what? A is also 2. So this becomes 4 pi. And 4 pi is there in the numerator. This comes what? 10 to the power minus 7 into 10 to the power 1. This gives 10 to the power minus 6. Now see the direction. This is the direction. This is the direction of the current flowing, and this is my point. So it is leading towards you people, means into the page, into the screen. That means inwards. I'll write it into the page. Into the page or inwards you'll write. Put a cross or write. That is your complete answer. You just need the direction. And if you're sure, most probably if it had it been a graph, then we would have written K cap as well. Now B part. B part is new for you. But remember B part. B part will not come directly, and especially for those who are preparing for their competitive exams, this B part, will help your calculations, because if you have the current element flowing, then at that point, at the same axis of it, the magnetic field becomes zero. If the magnetic field is at, or the point is located at the axis of the current element, like I'll show you. B is lying where? B is lying at the axis of it. Any point lies on the axis. This is not the axis. This point is not the axis. Any other point apart from it doesn't show the axis. At this line, then your magnetic field comes out to be zero, directly zero. So answer for the B part is zero. And if you have loads of calculation and your point is lying, we'll see that question. I'll give you the question, that question when we'll do semicircles. So B will be zero. For the C point, it will be 4 pi in the denominator. Why? Because it is semi-infinite. So this becomes 4 pi into 10 to the power minus 7. Current is 10, 4 pi, and R is 8. So 4 pi gets cancelled. This comes out to be 5 into 10 to the power minus 7. Now the direction. Direction will be the same, I think. Yes, direction will still be the same. Point is lying on that side only, no? So it will be inwards. Quickly note it down. We'll do one more question if two linear charges are given to you. Conductors are given to you. First, note it down quickly. Then I'll give you one more question. And also add K cap minus K cap also, in your answers, because it will be confusing when you will be studying. If you will try to find out the unit vectors, it will get confusing. So add the unit vector as well, because I told you unit vector is the best way to write, as you will get when you will have different figures. If you have single questions like this, then into the page and out of the page is fine. But when you will have multiple questions, then unit vectors are important. Now, two magnetic fields you will be having. So consider them as infinitely long wire only. Let me draw it. Complete infinitely long wire. At this P point, you have to calculate. So see, you will be having two values of magnetic field. So how to calculate? Check up the unit vectors according to it and solve it. Now for calculation of magnetic field at point P, let's consider the first wire then. What is the formula for magnetic field of an infinitely long wire, Zaid?
Uh, Ma'am, what is that sign known as that?
Mu naught, mu naught.
Nu naught I 2 pi A.
Mu naught I divided by 2 pi. That's right. So V1 will be what? Mu naught I divided by 2 pi A. Sneha, tell me the direction at this point P due to conductor 1. K cap, J cap, I cap, minus I cap. What is the direction? Unit vector. Or at least out of the page, into the page, any direction, just tell me. Sneha. Yes, Sneha? You're not audible, Sneha. I think it's better if you type your answer. Because whenever you speak, no, your voice is not useful. Just type the direction. Yes, for net EMF, for net, I was saying EMF, magnetic field, Z. Sneha, it is outwards, means K cap, positive K cap. Send me your answer, type your answer, Z. Meanwhile, rest are answering, just type your answer. How outwards? This is your conductor, A point, this P point is here. Curl your fingers towards this point. It is leading into the page. Clear? Tell me, Sneha, tell me for the second one. So into the page means inwards. This is which axis? Minus K cap. Tell me which unit vector will come for B2? Samira, can you answer this? Unit vector for B2, magnetic field because of conductor 2.
It will be a positive K cap.
Positive K cap, positive K cap or negative K cap?
Positive.
Positive. That symbol Z, it is mu. Mu naught. All right. Okay. 4 pi, 4 pi. Are you sure it's 3i? Just check. Just check once again. I'll also do it right now. I'm not sure about the answer, but just check. I think it's not 3i. K cap, yes, Sneha. K cap. Samira and Sneha, it will be K cap. See, this is your conductor. This is the point. P point is this. So if you curl your fingers, it is leading outwards. Outwards means positive Z axis. That is K cap. Now for the net magnetic field, you have to add it. Net magnetic field, at P point. This will be what? This will be equal to B1 plus B2. Write down the values of B1 plus B2. See, it will be equal to mu naught I by 2 pi A minus K cap is there, and this will be plus mu naught I by 2 pi A K cap. Here. Now, Current, let's put the values of it. So see, everything is the same. It's just that we have to replace the current because the vector position vector is also a. So we don't need to replace many things. So instead of writing it again, I'm adding 2 here only. This will be 2i and this will be 2i. So let's take common things common. Mu naught I k cap by 2 pi a can be taken as common. From here, -1 is left. From here, +2 is left. Understood the mistake, Zed? Because of minus k cap, this will be -1.
Yes.
All right. So the answer becomes 2 minus 1, that is 1 only. Mu naught I by 2 pi a. This is your final answer. Yeah, note it down. Then we'll move on to circular wire right now. Center, at the center, we'll do first. Yes, sir, that's now not included. The derivation of these two. This is included. Derivation of circular coil. So that we'll do right now. Circular coils, semicircular coils, semicircular arc, all these are included. That we'll do. So I think you people must have written it down. Now magnetic field at the center of circular coil. So this we'll do the derivation. Now see, circular coil is there. Different directions of current can be flow. It can be out clockwise. It can be anti-clockwise. In any way, it can come. Now see, for circular coil, circular wire, right hand thumb rule will give you the direction, but how to use it? Because it's not straight wire, no, that you can keep it at a specific length or how to do it. I will suggest you curl your fingers as the current is moving. Like if it's moving like this, current is moving clockwise, curl your fingers clockwise. Direction of magnetic field is given by the thumb. So that becomes easier to do in this way. This is the direction. This one. This I have taken randomly. It can be anti-clockwise. So take it like this. Anti-clockwise, direction of magnetic field. Right now we have consider a small element DL. This is current element DL. This is the direction of DL. Not current. This is direction of DL. Small current element that I have taken. Now the magnetic field due to this. Magnetic field due to element. Magnetic field due to this element using Biot-Savart's law. dB will be equal to what? dB will be equal to mu naught I by 4 pi. DL cross R also you can take DL cross R, because see, DL is making an angle of 90 degree with the radius. So even if you take DL cross R, sine 90 will give you 1 only divided by R cube in vector form if we write it. Or you can write it in normal form. Non-vector form. So dB will be equal to what? Mu naught I dl sine 90 divided by 4 pi into r square. This will be the formula. Now eliminating sine theta, this gives mu naught I dl divided by 4 pi r square. Now see, dl, what is dl? And we have taken dB. So we have to find out for the whole. I have told you when we were discussing electric potential and capacitance, if you know a small quantity and you want to find out for the whole one, like if you know the length of the smallest infinitesimal piece of rod and you want to find out the complete length of rod, you integrate it. Similarly, we'll integrate this. We'll perform integration. We'll actually integrate this whole. We'll integrate this. So rest of the things are constant. What will be left? Mu naught I by 4 pi capital R square, integration of DL is only left. See, if you add all the current elements together, what will it give you? Can anyone tell what will be the integration of DL? Yes, there?
2 pi r.
2 pi R, exactly. See, if you add all the current element, that will give you complete length of the circle. What is the length or the circumference of a circle? 2 pi R. So just put 2 pi R. So B, this is integration, no? B will be mu naught I by 4 pi R square. DL will be 2 pi R. 1 R gets cancelled. Pi gets cancelled. 2 becomes 2. So magnetic field for a circular wire, this is given by mu naught I divided by 2. Note down this derivation. Then semicircular one is very easy. But remember, pi doesn't come in the formula of circle. Suppose the coil doesn't have a single loop. N number of turns are present. So multiply it with n. N is the number of turns. Then the formula becomes mu naught I by 2r is there. It will become n times this. And I'll write down the modified right hand thumb rule as well. Direction. This will be given by right hand thumb rule. Means you have to curl your fingers along the sense of current, as I've told you. Along the sense of current means clockwise or anti-clockwise. This will be understood when we'll do questions. Gives direction of magnetic field. Add these 2 points as well into your notes. Like, let me let's say this is one and this is another. Current is flowing in this direction, current is flowing in. This is first one, this is second one. Answer. What will be the direction of magnetic field for first and second? All of you should answer this.
Ma'am, can we do in the chat?
Z in the chat. Inwards, outward, simply inwards, outward. All of you should write. Curl your fingers along the direction of current, the way current is flowing. Wherever is your thumb pointing, right, left, upwards, downwards, into the page, out of the page. Write it in the chat box. Samaira, correct. Zaid, first one, yes, right. Khalid, right. Second one is also correct, both of you, Zaid and Khalid. So Zaid, Khalid, and Samaira. What about Sneha? Yes, correct. For the first one, no? Perfect. See, if you curl your fingers along the sense of current, this will be the direction. And second one, okay, Sneha, good. Thumb is pointing into the page. This will be inwards. And try to be familiar with these symbols because most of the time in questions, inwards, outwards is not written. And this
Ma'am,
will
we can
be
use here like right hand thumb screw rule.
right hand thumb rule only. Yes, right hand thumb rule also. If you take the current element and draw it, same answer you get. That also you can use. And because sometimes what will happen, we don't have time to take the tangent and draw. If you're able to do it, then perfect, do it. Otherwise, we are using only our right hand only in this. Only right hand we are using for all the rules because I've told you, other hands will come, it will become confusing. So yeah, we are using right hand only. So this is the sense of movement of current. This is the direction, that is out. So perfect. Just add these point as well out. Because in semicircular will not take so much time. Just try this first. We'll do semicircular also. Just text me done when you people have written it so that we can do semicircular one as well. Only these points. Okay, Samaira has done others. Samaira, Sneha, done. Others, have you written? Khalid and Zaid and all.
Yes, teacher, done.
See, semicircular one, since the calculation is same, I'll write it down here also. But you people don't make it in your notes. You have to write it again. Since I'll be able to erase it over here, I am writing here. So this becomes for a semicircular wire. For a semicircular wire, this part will get removed. Rest of the things will remain the same. And at one more place, can anyone tell me what will be DL for semicircular one? DL plus DL plus DL plus DL for a semicircular wire. Circular was given by Z, 2 pi r. For a semicircular one,
Pi r.
pi r. So, yes, Samira. It will be pi r. So this is mu naught I, because circumference of semicircle is what? DL, 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 DL gets added. So this is mu naught by 4 pi r square. Okay, Khalid. Fine. Into pi r. So r gets cancelled, pi gets cancelled. V is equal to mu naught I by 4r. This becomes the formula. And the changes that will come here, this will also become 4. If n number of turns are there. So don't write down the direction again, because direction once written, that will help. But you people have to note down the derivation once again. Make the heading as semicircular wire. Quickly note it fast, because you know the difference will just come in that DL portion. Because in your exam, separate question will come. If you mix it in your the way I have done, then you won't be able to find out for the circular one. So write it down again. And make the semicircle also, because earlier it was a circle. No? One last case is left, semicircular arc. Arc means not a complete semicircle. Semicircle subtends the angle of 180 degree at the center. No, random arc is there, any making any angle. That also let's see. So first note this down, then that means the derivation also same. The difference will come in DL only.
Ma'am, can you show the first starting of this one? Yeah, okay, ma'am.
And don't copy the direction. Direction is the same. So you can see it once. But yeah, write it down, this part. And just let me know when you all have written, so that we can complete the last part as well. Written. Let me redraw the figure for the circular arc. See, circular arc means a random arc like this, which is subtending a random angle. Semicircular is a special type of arc. Semicircular is basically an arc that subtends an angle of 180 degree at the center. Change the heading also when you people are writing down. So this is the flow of current. Again, direction will be along the sense of current. Let's say the radii is r, this radius is r, making an angle of alpha at the center. Arc is subtending alpha at the center. Now the changes that will come in DL. This is just important. Rest of the things you people know how to solve it. See, in case of DL, does anyone know the relation between length of arc, radius, and angle? Anyone? Because I think this must be included in your 10th or 9th class in maths. Anyone? Length of arc, angle, and radius. No one?
Ma'am, L equal to theta by r.
Theta into r.
Theta into.
So see, dl will be equal to what? dl, I'll write down it also. Length of arc. This is equal to angle that it subtends multiplied by the radius. So our dl will be equal to alpha r over 4. That's the difference that comes. So just put it as alpha. B will be equal to what? Mu naught I by 4 pi r square into alpha r. R gets cancelled. B becomes mu naught I alpha divided by 4 pi r. This is a little different than the previous one. Here pi is included in the denominator. And number of turns, B will be equal to n mu naught I alpha divided by 4 pi r. Another derivation also completed in 3 to 4 seconds. So, but you people have to write it down because of the disadvantages of the derivations that come in your exam. So just note this down again. Last derivation. No other derivation will do. But I think by writing this third time, you will be able to remember it. The steps will be easy. It's just that you have to remember the DL that comes, value of DL. So write down done when you all have written it down in the chat box. Just text me done. Okay, Samira and who else? Apart from Samira, Sneha done? Others? Not Khalid, this Salman. Salman written?